Exo Nano came from my research at Brigham Young University. I was doing my undergrad and discovered a new material. I created a company and we started licensing and making product. Smartfoam is a foam that changes electrically when you impact it or apply pressure to it. So we can measure that and we can put it into products like football helmets or shoes. What our insole will be used for is to identify anomalies that indicate injury is going to happen. And then what we'll do is we'll train those soldiers how to strengthen those weaknesses that they may have in their gait and therefore reduce the number of injuries that the soldiers will sustain.
My name is Jake Merrill, President and inventor of XO-Nano Smartfoam. Today I will be presenting our smartfoam-enabled, insole-based training device for U.S. Army combat training and recruiting. Smartfoam is our patented foam-based sensor that is capable of measuring pressure and impacts in any foam-based product. Today we will demonstrate how smartfoam can enable a whole new level of smarter training that is based in your shoe. The Army has been training some of the most prepared soldiers in the world for nearly 250 years. Training has changed during this time to better prepare soldiers for current world conditions and higher lethality. As a matter of fact, a new Army combat fitness test is starting to roll out right now. The goals of this new test are to improve soldier and unit readiness, transform the Army's fitness culture, reduce preventable injuries and attrition, and enhance mental toughness and stamina. This change comes at a time when the cost of injury is becoming more apparent. A 2017 U.S. Army study found that 43% of 143,000 basic combat trainees evaluated had at least one lower musculoskeletal injury during their training. According to a military medicine journal paper published in March of this year, non-combat musculoskeletal injuries may account for nearly 60% of soldiers' limited duty days and 65% of the soldiers who cannot deploy for medical reasons. These injuries not only cost the Army an estimated $434 million each year in direct medical costs, but they also largely contribute to the 13% attrition rate, which costs the Army an additional $300 million every year. Not to mention the more than 8 million limited duty days recorded in 2018 alone. Time will tell how well the Army's new combat-focused test and training program will prepare soldiers for combat and reduce preventable injuries. However, results are showing that there is a high failure rate. An estimated 30% of men and 84% of women are failing this new test. These numbers are staggering and demonstrate the need for change within the Army's training system. Another group of highly trained individuals that operate on the line between injury and high performance are elite athletes. When they want to take their performance to the next level, they go to human performance labs where exercise physiologists use force plates and motion capture devices to assess their performance. They then receive detailed reports with tailored recommendations designed to optimize performance and reduce the likelihood of injury. This process continues to ensure they are always on their A game. Obviously, it isn't practical to bring every Army recruit into the lab and have an exercise physiologist provide detailed recommendations to them. However, with the advancements in sensor technology and artificial intelligence, we can bring these benefits to a larger population. XO-Nano Smartfoam sensors provide lab-accurate force measurement in an insole-based system. These plots are from one of several different peer-reviewed journal papers that show how smartfoam sensors can measure the forces a user's foot applies to the ground. The gray plots in the background represent all steps in the test. The black line represents a random step force trace measured by a $200,000 instrumented treadmill. And the dotted red line represents the insole's measured force trace. These measurements, along with the user's motion data, are the tools that physiologists use to develop their recommended training to their patients. We use these same data sets in combination with an advanced artificial intelligence, called Holmes, to create science-based real-time feedback and training recommendations to each user. These results are available in a phone-based app for real-time or post-workout reference for the user or for an administrator. This smart insole brings a high-tech lab and physiologist to the boots and running shoes of every soldier in the U.S. Army and will accomplish 4 distinct objectives. First, validate and recruit the best candidates for training. Second, optimize training for each trainee so they can develop more quickly. Third, reduce injuries by providing personalized training to strengthen each trainee's weakness. And fourth, ensure soldiers remain combat ready with continued training and personalized feedback. This will fundamentally change the way the Army trains and maintains its soldiers moving forward. Before we launch into the full demo of our technology, I want to give some background on how XO-Nano Smartfoam was created. It was developed during my doctoral work at Brigham Young University. Smartfoam has two electrical characteristics that enable this highly accurate smart insole. This foam's piezoelectric response, or what we've referred to as XO Nano impact sensing, allows us to measure the dynamic forces that are applied to the foot. And the foam's piezoresistive response, or XO Nano pressure sensing, allows us to measure the static or constant loads. Smartfoam is manufactured by our partner, Rogers Corporation, who has been supplying high-quality foam to the shoe and insole industry for many years. This foam in its entirety is a sensor. Electrodes are conductively adhered to the surface of the foam to measure its electrical response to force. This is an example of an electrode that is used in the insole to measure the electrical response at 6 distinct locations: medial and lateral heel, posterior and anterior arch, and medial and lateral ball. A microcontroller is connected to the printed circuit to measure both the foam response as well as inertial measurements and transmits these data via Bluetooth to our companion tablet app. During development, it is easier to keep the electronics outside of the insole for debugging and troubleshooting. We have some prototypes with everything completely contained in the insole, which is how the final product will be produced. Our partnership with Jumpstart CSR, the creator of Holmes, is helping us realize the full potential of lab-accurate force measurement insoles in a real-world environment. Holmes is an AI that predicts, prevents, and improves biomechanical performance. Holmes converts high-quality data streams into actionable insights and recommendations. Holmes consists of a human dynamic model, a cognitive expert system, and a user interface. The human dynamic model encompasses biomechanics, physiology, and physiometrics to create a digital self. The cognitive expert system evaluates raw data from the insole and output from the human dynamic model to create insights and recommendations through a variety of reports, including adaptive training plans, injury risk assessments, and readiness to perform. And, just like an expert, Holmes provides the rationale behind its insights and recommendations as a report inspired by medical and scientific research papers. Holmes puts an end to AI black box while keeping the feedback simple and actionable. This is a demonstration of what the user interface could look like during the recruiting process, training, or during enlistment, with minor adjustments to highlight the needs in each group. In some cases, registration may be required. However, all users would need to put in their biomechanical measurements to populate the human dynamic model for increased AI accuracy. Once all of the user's personal information is filled out and the insoles are connected to the app, they will proceed to the functional tests. These functional tests are used to determine baseline fitness, biomechanic form, and potential risk of injury. The tests can include activities such as walking, jump tests, and balance exercises. These tests could be carried out by potential recruits to determine if a formal offer should be extended to them, thereby reducing the number of trainees invited to camp that are unfit for basic combat training. However, these tests are used to create personalized training plans for those that are at basic training or are enlisted. A report is generated that outlines the results after each individual test. Once all tests are completed, a composite results summary highlights your performance, injury risk, and readiness to perform with the model's associated confidence. This report also indicates specific muscle groups that will be targeted in the training to increase performance and reduce the risk of injury. The recommended training plan is then generated with specific exercises along with a schedule to follow. This is an example of a recommended training plan. Holmes will track each user's training history and provide helpful indicators of their progress during their training. This training plan isn't intended to replace the current training that recruits undergo, but is meant to augment their training to ensure optimized training results. Detailed reports provide insight into each recruit's overall training, highlighting their readiness to perform with clear indicators of potential risk. This one shows there is a high risk of musculoskeletal stress, specifically on the left ankle. Once a risk is identified, an instructor or administrator and the user would be notified, and specific changes to their training would be recommended to prevent injury. The new Army Combat Fitness Test consists of 6 different activities. For our proof of concept, we focused on the 2-mile run. We created a biomechanical model within Holmes that took into account all of my measurements, and I ran 2 miles in BYU's exercise science lab. We recorded the data from the lab equipment and both smart insoles to validate the Holmes model. Our insole-based solution was able to reproduce ground reaction force data with 98% accuracy, provide a biomechanical model of the foot and ankle with 98% accuracy, the knee with 84% accuracy, and the hip with 60% accuracy. The accuracy of the model decreases as you move up the body because we are measuring inertial motion at the feet with a triaxial accelerometer. However, we are currently upgrading it to a 9-axis IMU to increase this accuracy. This screen shows real-time data from a run I performed outside where the actual training occurs. As you can see, we see live stats of my performance, readiness to perform, repetitive stress injury risk, gait effectiveness, and biomechanics. In order to predict physiology, heart rate information would need to be collected. Our model also provides more details within each area. Here you can see the likelihood of injury for my hips, knees, ankles, and feet. You can also see more detail on my gait effectiveness. The first 5 columns demonstrate measurements during the stance phase, while the last 3 represent measurements during the swing phase of my gait. Measurements like postural sway, asymmetry, power, and peak power, among others, are presented. Additional details are found under the other headings as well. We are extremely excited about these results and look forward to providing the Army with the expertise, complexity, size, and cost of a professional exercise science lab in a convenient, portable, individualized, and cost-effective insole. The xTechSearch program has provided our company with many resources to help us move this project forward very quickly. We have had excellent mentors and introductions to prime contractors, key Army decision makers, and investors, not to mention the $135,000 non-equity funds awarded to date. In order to maintain this momentum and ensure this product comes to the market, we have created a transition plan that is outlined in this timeline. There is a lot here, so I will touch on the most important and immediate items first. We are finalizing the design for our next generation insole electronics to allow for several key third parties to begin testing, including Under Armour and West Point. Under Armour is excited to start testing in the next couple of months and sees potential in using these insoles to revolutionize human performance. We are finalizing the details on a statement of work with West Point, which would result in an initial trial of 100 insoles for new cadets in the spring of 2021. We've had several discussions with the Air Force's 711th Human Performance Wing and are preparing an AFWERX application for submission next month. We see these insoles as a game changer for the Army and consumer markets, but we have also seen great interest from the public health sector. We have had in-depth discussions with a major national healthcare company about the immense capabilities of a diabetic pressure sensing insole. We have also received overwhelming interest from members of the greater physical therapy industry about the future of at-home rehabilitation and training. We will finalize development of these derivative products in the next 6 months and begin introducing them to the market within the next year. To accomplish these objectives and bring XO Nano Smartfoam technology to these markets, we need to identify critical partners to effectively scale and distribute this technology. In 5 years, we plan to be a leading technology shaping the consumer, military, healthcare, and professional athletic training industries. In order to give our company the best chance of success, we have created a team both internal and external to XO Nano that covers all the bases. The immediate XO Nano team consists of 3 electrical engineers, 2 mechanical engineers, an MD, an MBA, and a former college football coach. Additionally, we have partnered with Jumpstart CSR, who will continue to develop the Holmes AI and user interface. We have a CRADA with U.S. Army Research Institute of Environmental Medicine to ensure we create a product that can be used for continued Army research. We continue to collaborate with both BYU's and UNC's exercise science departments, as well as UCSD's Armor Lab on related research projects. Finally, we are able to work with our manufacturing partners, Rogers Corporation and RAM Technologies, to take advantage of their many years of experience in the insole industry.